The purpose of this lab practice was to make an aluminium casting through sand casting and learn and understand the different stages within this process.
We used a green sand mix, aluminum scrap. Also, we used talcum powder and some chlorine flux. We used some tool for a furnace and a mold. And we used also some others casting tools and safety equipment.
First, we turn on the ceramic oven to preheat it for 30 minutes and then add the aluminum scrap in a crisol. While this was happening, we prepared the green sand by making it thinner with a shovel and adding bentonite to achieve the consistency.
We put inside the press cage the melt pattern, add some talcum powder for making easier the extraction, and fill it with the sand. We made sure that it was well compacted. Then we turn around the cage and clean the other side of the pattern with compressed air. After this, we add the other half of the cage and add some sand. In this part we put two metal cylinders for later use the holes as screw holes and risers. We fill the cage with sand, we compacted it and create some vents so the heat could emerge easily.
Then we remove the pattern carefully and we observe that the sand took the shape. It was ready to fill it with the molten aluminum. We take out from the oven the crisol that contained the molten aluminum and pour it through the sphere holes. We finally wait for solidification complete. We separate the two cages and remove the piece.
One advantage of the green sand molding is that you can make complex and large geometries, and the scrap can be recycled. And also you have many material options. And one of the best advantages is that the tools and equipment are very cheap. Of the molding green sand is that the process is very expensive because you can only have few pieces at the time. The production is low because the mold cannot be reused. You have to destroy the mold to take the piece you make in one process, and you have to build a second mold to have the second piece. You can also have poor surface finish and tolerances, so often you require further machining.
The contraction cavity can be avoided by using a riser. For example, in our piece, the screw holes were for bursting the liquid aluminum, but they work as risers too, making more difficult the pipes. When the solidification process was finished, we could look some defects in our piece, some like ruggedness that could be produced by a small mistake when we compacting the sand, or by the pouring rate that must be constant in order to obtain a uniform surface. The most common defect in our piece was the gas porosity, perhaps caused by bulbous gas trapped within a casting during solidification.
Degassing in aluminium is the removal of hydrogen dissolved in the molten aluminium. It is necessary to degas the molten aluminium because the solubility of gaseous hydrogen is 44 times greater in molten aluminium than in solid aluminium. This causes an excess release of hydrogen during solidification, which eventually leads to porosity defects throughout the casting. Degassing can be performed through several methods. For example, a very slow and controlled solidification can help, or there's also the vacuum method. However, for this lab practice, we degassed the aluminium with the aid of a flux. We used fluxes which are composed of chlorine and fluorine in the form of a tablet which is placed within the molten aluminium until the bubbling ceases. This helps to remove part of the hydrogen from the aluminium to reduce the effects of porosity.
A mail mold is the one used when the material is fabricated or grow over the surface of the mold. It is quicker to construct, but it has the worst finishing. In sand casting, we first use a mail mold in one half of the cage because the sand covers the outer surface. Then the mold is removed and the shape remains in the sand that is later used as a female mold because the molten aluminum fills the cavity.
In this practice, we assume that the object to cast was a smooth surface plate with dimensions of 1 cm per height, 18 centimeters of large and 12 centimeters of width. So to make the calculations easier, and our time of waiting till solidification was 60 minutes, we calculated the constant of the mold and is 31.13 minutes per centimeter square.
Practice helped me understand the sand casting process and learn about the different cares we have to take throughout the whole thing when making the mold.
In this practice, I learned step by step the process of sand casting. I understood why it is a slow method. It releases a single piece and the mold is destroyed. But I noticed that it is simple and that we didn't require specialized or expensive tools.
I learned every step to sand cast a piece and importance to do it good because of defects like porosity or pipes, and the solution like the use of risers, and the difference between the theoretically and the reality.
In this practice, I could see how a casting process is performed, and for me it was very important because I was curious about this process. The most interesting thing was that in our piece we have several defects and we must to determine the cause and its solution.
I learned how really the porosity looks like in a casting piece.